Hello everyone, I hope you are all well. I'm now going to go through these 10 questions. So firstly, we have a logarithm function with base 3, and we need to work out what x is. So remember, when we first learnt about logarithms, we said that a logarithm function is the inverse of an exponential function. So for example, if you have, let's say, 2 to the 3 equals 8, then log base 2, 8 equals the index, so this 3. So we're going to use the same principle for this first part. Base 3, the index is -1/2 equals x. Now we need to work out what x is, so I'm going to write 3 to the -1/2. Of course, that's the same as 1/3 to the half, which equals 1/√3. Moving on to question 2, or I should say 1 part 2. I notice this 2 in front of log x. So firstly, using my understanding of the log power law, 2 log x is the same as log x squared. Now we have a new equation, and on the left hand side we have a sum. And since these two logs have the same base, we can multiply the terms on the inside of the bracket together. So now I'm going to write log, just a single log function, open bracket, x squared multiplied by 10, because we're adding these together. So 10x squared equals log 90. So of course that means 10x squared equals 90. Divide both sides by 10, we get x squared equals 9. X equals 3 or -3. However, because this is a logarithms question and we have a log x here, x has to only take a positive value. And so we're going to cross out this -3, because log x can only take positive x values which are larger than 0. Moving on to part 3. Using the same logic as part 1, 10 to the power of -3 equals 1/x. So 1, 2, 3. 10 to the -3 is 0.01, which as a fraction is 1/100. So x equals 100. Moving on to part 4. Again, it's similar to part 2. I've noticed this addition sign and 2 log functions with the same base. So I'll write log x multiplied by y equals, and again I notice this value in front of the log. So I'll write log 9y squared to the power of 1/2. So log x y equals log 9 to, so square root of 9 is 3, square root of y squared is y, of course. So just looking at this equation, I can clearly see that x is equal to 3. And you might be thinking, okay, how are we supposed to work out the y? But think about it like this. If you substituted y equals 100 into this equation, you would get here log x multiplied by 100, and so 3 multiplied by 100, so log 300. Here we have log 3 multiplied by 100. If you were to substitute y equals 5, then we get log 15 equals log 15. So y can take any value. Y can take any value. It just has to be larger than 0, just because that's just a rule for logarithms. They have to take values which are larger than 0. Question 2. Show that the equation of the line can be written. Okay, so we're going to use our understanding of y equals mx plus c, of gradients, y-intercepts, x-intercepts, to show that this equation corresponds to this line. So I'll write up here x over y plus y over b equals 1. I want to make y the subject, so I'll add these fractions together. So b x b multiply y over b by a over a, so we get ay over ab equals 1. Bx plus ay over ab equals 1. Multiply both sides by ab. And remember, we want to make y the subject, so I'll write ay for now. Ab take away bx. Divide both sides by a, so we get y equals b, take away b over a. X, of course. So now we have an equation in the form of y equals mx plus c. Now there's a few things I can use to show that these two are the same. I could look at the gradient, and the fact that it's a negative gradient, it makes sense that these two are the same. The y-intercept is b here, and I can see it corresponds to the diagram, so that's another thing which is consistent. Now we need to check the x-intercept. So for the x-intercept, y has to be 0, so I'll substitute y equals 0 into the equation above. So y equals 0, 0 equals b take away b over a x. So add b over a x to both sides, you get b equals b over a x. And so if you multiply both sides by a and then divide both sides by b, you have x by itself, and of course these b's cancel out with one another, so x equals a. And now we can tick this one off as well. Here we have a question from a past trigonometry topic assessment, which a lot of students found difficult. Understandably so, there's a lot of information, there's a diagram there, but it is quite difficult to transfer this information onto the diagram. So I'm going to go through the question first. So Marissa is on a Ferris wheel watched by a friend who is directly below the wheel. Tash looks up and sees Marissa's capsule directly overhead in position M1. Exactly 150 seconds later, it's onto M2. So I'll write here 150 seconds between the capsule going from M1 to M2. The Ferris wheel turns anti-clockwise. Okay, cool. Given that the Ferris wheel has radius 15, now this is quite important, and it's going at constant speed, that Tash is at a horizontal distance of 9 meters, and they've denoted that here. Work out how long the Ferris wheel takes to make one full revolution. So, how long does it take to make one full revolution? So I'm assuming what they mean by that is how long does it take for the Ferris wheel to turn one whole circle? So if it starts here, how long does it take for it to go around and then end up here again? So I'm going to try to use a few different colors to annotate just so it doesn't look too messy. Firstly, so the 9 meters is there already, but 15 meters is the radius of the Ferris wheel. So I'll draw a dotted line to make it clear what the radius is. So 15 meters, 15 meters. I'll draw a line here as well going down, and now we have a triangle, and of course now it links to trigonometry. We can see there's a triangle here, so we can use some trig now, hopefully. Now look at this 9 meters here. I'm gonna draw a line going down like this, of course right angle, and I'm gonna write 9 meters. Now what I want to do is work out the angle. I want to work out this angle here. And bearing in mind, I know that it takes 150 seconds for the capsule to turn x degrees here. Then I'll be able to use my knowledge of ratio to work out how long it will take for it to turn 360 degrees, because of course that's a full circle. So let's see what we can do here. So we have a triangle. (15, 9), and we're concerned about this angle here. I was just seeing, can I use cosine rule? No. Not enough information. So yeah, I have to split them into two right angle triangles. Okay, so hypotenuse, opposite, adjacent. Actually, I'm going to work out this angle instead. I'll tell you why in a second. So apologies, let me start again. Alright, what I'm going to do is work out this angle. Then I know that these two angles will be the same because the triangle the blue triangle is an isosceles triangle. Since these two angles are the same, then I can work out the third angle because angles in a triangle add up to 180 degrees. So let me draw this right angle again. Right angle triangle, sorry. Here, 9, 15. Opposite hypotenuse, sine. Opposite over hypotenuse is 9 over 15 equals, I'll call it theta, maybe. Yeah, let's call it theta. So arc sine 9 over 15. If you type that into a calculator, you get 36.9 to 1 decimal place. And so now I know that this is 36.9. This is 36.9. Angles in a triangle add up to 180. So I write, okay, that's not very good. Oh, that's a pen. Sorry, that's a highlighter. I'll write 180 take away 36.9 multiplied by 2, or I could just write take away 36.9 again. Doesn't make a difference. Equals 106.2 degrees. Yes. So I've worked out the angle X. We'll round it to 1 decimal place, that is. And I know that it takes 150 seconds. It takes 150 seconds for the Ferris wheel to, for the capsule to turn 106 degrees. So how long does it take for the capsule to turn 360 degrees? So how do we get from 106.2 to 360? Alright, multiply by 360 over 106.2, because 106.2 multiplied by 360 over 106.2 would give you 360. And so we need to do the same thing on the other side. And so if I write 150 multiplied by 360 over 106.2, typing that into a calculator, I get 508.5 seconds. So that's how long it takes for a Ferris wheel to make one full revolution. Question 4. The cost of building a lighthouse is proportional to the cube of its height, h. So just by looking at that first sentence, I'm going to write C equals K h cubed. The distance that the top of a lighthouse can be seen from a point at sea level is modeled by this equation, where r is the radius of the Earth and d, r, and h are in the same unit. So one thing I notice about r here is that it's a constant. So regardless of what the distance is, r will always be the same. 3 possible designs X, Y, and Z are considered, in which the top of a lighthouse can be seen at 20 kilometers, 40 kilometers, and 60 kilometers. Okay, so we have 3 different distances. It's quite clear from that. So right here, dx equals 20, dy equals 40, dz equals 60. Find the ratios of the costs of the designs. So we need to find three different c values, cx, cy, and cz. So if dx equals 20, then what is h going? So we're going to have three different h values, okay. So I will write, let's change the pen color. Sorry. D equals root 2. I'm going to rearrange. Alright, d squared equals 2rh. And then d squared over 2r equals h. So we have 20 squared over 2r equals hx. 40 squared over 2r equals hy. And 60 squared over 2r equals hz. Sorry, I should make it clear that the x and y here are just subscripts. So the h has to be bigger. Yeah, so 20 squared is 400. So here we have 600, 3600 over, and I'm going to disregard the 2r, all the 2r's, because they're all the same. I'll now work with this 400, 1636. Actually, I'll have to keep it there, sorry. Okay, so let's simplify it. 200 are, 800 over r. 800 over. Alright, now we're going to work out three different c values. So I'll write cx equals k 200 over r all cubed. Okay, I am aware that they're all going to have k over r cubed, so it's not really, we don't need to work with that k over r cubed, so I'll just rewrite it using a new constant. I'll call it, let's just use p for the sake of it. P multiplied by 200 cubed, so 200 cubed is 800,000,000. Then cy or cz, they'll both have a constant in there, with the constant being k over r cubed. And here we have 8 multiplied by 8. 6, okay, it's better I use a calculator for this to avoid making mistakes. So 800 cubed, 512, 6 zeros. So 1, 2, 3, 4, 5, 6. Alright, now I can find the ratios. Well, I actually have a ratio here. I have 8. How many zeros is that? 8 million to 512 million to 8 million to 512 million to 5 billion and 832. So I've simplified it by just removing the 6. They all have 6 zeros, right? Yeah. So I've just removed them. Now if we divide it all by 8, well, of course, 8 divided by 8 is 1. 64. Then 512 divided by 8 is 64. And 5,832 divided by 8 is 729. So now we found the ratios of the costs of designs X, Y, and Z. Moving on to question 5. Firstly, thank you to Ali Raza who sent this question in and I guess gave me the idea to include it on this lesson. So we have a spheres question involving the area, so the surface area of a sphere and a volume of a sphere. So before even reading the question, I'm going to write the surface area of a sphere, the general form, and the general form for the volume of a sphere. So 4 pi r squared, 4 over 3 pi r cubed. So now looking at the question, show that A, as in the area, equals kV to the power of 2 over 3, where K is this value. Okay, so let's write capital A equals 4 pi, and just because it's a capital R in the question, I'll write R squared. Volume equals 4 over 3 pi r cubed. Now, it's a show that question, and so we want to work this A out using A and V to the 2 over 3. So I'm gonna write V 2 over 3. So that'll be 4 over 3 to the power of 2 over 3 pi to the power of 2 over 3, and r, cube root of r cubed squared would give you r squared. So that's nice. Now I'm gonna use these two to work out Q. And that's because I know A divided by 3 equals K. So now I'm going to do A divided by V to the power of 2 over 3. So we have, where should I write it? I'll write it here. Okay. 4 pi r squared over 4 over 3 pi 2 3 r squared. I'm just going to write the same thing again, but I'll align it so that it's a bit easier for us to simplify this complicated fraction. 2 over 3, and I'll leave a little gap, right, pi 2 3 2/3, I should say, r squared. Now it's a bit easier for us to cancel out some of these terms. So firstly, r squared divided by r squared, well, they just cancel out with one another. This pi here is pi to the 1, so it's pi to the 3 over 3. And so pi to the 3 over 3 divided by pi to the 2 over 3 is pi to the 1 over 3. So bear that in mind. I'll write it here. Equals, and I'll just write 4 over 3 2 over 3 for now. Okay, let's see, how are we gonna go about simplifying this? So let me use a different color pen. I'm gonna write 4 over 3 2 over 3 equals, okay, 4 squared is 16, 3 squared is 9 to the power of 1 over 3. And so now that means we have 4 divided by 16 over 9 by, so we have 4 multiplied by 9 over 16 to the 1 over 3. Now I really want to simplify this expression, and so I want to change how I'm writing the 4. I want to change the form it's in. So I just want some space somewhere on the page to write multiply the x with 9 over 16, and then I'll have one value to the power of 1 over 3. And so that means 64 to the power of 1 over 3 is 4. So now I'm going to write, I'm kind of running out of space, but I'll write 64 multiplied by, okay, I'm going to rub out some information up here. So you have 4 multiplied by 9 over 16 equals 64 to the 1 over 3 multiplied by 9 over 16, 1 over 3, pi 1 over 3. So we have 64 multiplied by 9 over 16 to the 1 over 3 pi to the power of 1 over 3. So 64 over 16 is 4. 4 times 9 is 36. So I have 36 to the power of 1 over 3 pi to the power of 1 over 3. And bear in mind, this is equal to k. We have cube root of 36 pi is equal to k. Question 6, we have two right-angled triangles. The lines AB and BC are equal in length. Okay, so I'll write these lines here. I'll add these lines here. These dashes. Equal in length and they're perpendicular. So there's a right angle here. Show the triangles ABE and BCD are congruent. So we know, okay, given that these two sides are the same, I know that this angle here is 90 take away theta. Because angles in a straight line, angles in a triangle have to add up to 180. The third one has to be 90 take away theta. Then we have an angle here, which is 90. I'm just going to change the color to make this very clear. 90 take away 90 take away theta. So I'll write 90 take away the other angle. So that gives us theta. Yeah. And so if that's theta and we have a 90-degree angle here, this third angle has to be 90 take away theta. So it's always useful to draw the triangles out separately. We have ABE here. ABE and BDC. Okay, first thing we can establish is that they have the same exact angles. This is the same, and they have the same hypotenuse. So the fact that they have the same three angles means that these two triangles are either exactly the same or one is an enlargement of the other. But if one was an enlargement of the other, then the scale factor between the corresponding sides, the scale factor between this side and this side, would have to be the same as the scale factor between this side and this side, and the scale factor between this side and this side. But we know that AB is equal to BC. So you could say the scale factor between AB and BC is 1, which means they're the same. And so that means CD is equal to BE and AE is equal to BD. So we've proven that they're congruent, and I mean I just demonstrated using SSS, but you could have even said ASA. From the moment we worked out that their angles are the same, and in the question we were given that AB equals BC, you could have written they're congruent by ASA. But I just wanted to show you why all the lengths are the same. Hence, prove that the gradients M1 and M2 satisfy M1, M2 equals -1. So gradient M1 is of course the change in y over change in x. So the change in y is BE, the length BE. Change in x is AE. So I will write M1 equals BE over AE. M2 is so negative because of course it's a negative gradient, negative BD over CD. So I'm going to use these facts here. M1 is equal to, I'll write CD over, and I'll replace the AE with BD here. And so now M1 multiplied by M2 equals CD over BD multiplied by BD over CD, which of course equals -1. Alright, so question 7 is a binomial expansion question. And as I said in my clue, you can tell by how many terms there are, you can tell what the n value will be. So remember in Pascal's triangle, the first term is 1, and that means your n value is 0. If you have 2 terms, n equals 1. So for example, a plus b to the 1 will give you 2 terms. Then we have 1 to 1, n equals 2, which of course is a quadratic equation, and so on and so forth. So we have 3 here, 3, 1, n equals 3. As you can see, the number of terms is 1 larger than the number of n. So here we have 1, 2, 3, 4, 5, 6. 6 terms, so n equals 5. A is, okay, we need to work out A as well. So I know that this first term here is a to the n. So it's a to the 5 a to the 5 is equal to 243 over 32. So a equals the fifth root, 243 over 32, which equals just let me type this using the calculator, 3 over 2. So a nice simple fraction. So we worked out a. Now we're going to look at the second term here. So the second term is 5 choose 4 5 choose 4 a, so in this case 3 over 2 4, and negative kx to the power of 1 equals negative 405 over 4x to the 3 over 2. Okay, so now we need to simplify. 5 3 over 2, 16, no, 16, 81. Leave that like this. So I'm going to divide both sides by negative 5. So this becomes positive and this is 20. Divide both sides by 81 over 16. So kxm equals multiplying these two fractions together gives us 4. And so k equals 4 and m equals 3 over 2. So we have worked out a, k, m, and n. Now we need to work out the value of, as in now we need to use all this information to actually answer the question, which is work out the value of p. So I can see a p here. Let me change my color. Px to the 6 equals, so it's the fifth term, so I'm going to write 5 choose, so here was choose 4, 3, 2, 1, 5 choose 1, a to the 1 multiplied by k x so negative k x to the 4, so that's 5. Alright, I'll leave it as a for now. Then negative k to the power of 4 is k to the power of 4. and x for m. Now I'm going to substitute our values in. 5 multiplied by 3 over, was it 3 over 2? Yes, it was 3 over 2. Multiplied by 4 to the power of 4 to the power of 4 multiplied by x 4 multiplied by 3 over 2. So we have 5 multiplied by 3 over 2, 15 over 2, 15 over 2 multiplied by 256, x to the power of 6. That's nice because we have x to the 6 here as well. So P is 15 over 2 multiplied by 256, and so P equals 1920. Question 8, PQRS is a square of side A. So I'll write A, 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 A. And PQT is an equilateral triangle, so that's quite helpful. We can write A here as well. Find the lengths of the sides of the triangle QRT in terms of A. So firstly, I already know QT and QR. So QT and QR are both equal to A. And so we need to work out the side RT. So we have an isosceles triangle, and you know, another thing I could do now is label the angles as well. So these 60 degrees, 60. This will be 30 degrees, 30. Let me draw another. Okay, so since QRT is an isosceles triangle, these two angles have to be the same. So 180 take away 30 is 150. 150 divided by 2 is 75. Sorry, it's not too visible. 75. Okay, so let's see. Does that help? We could use the sine rule or the cosine rule to find the length of RT. So let's try the sine rule. So using the sine rule, RT is, so RT over sine 30 equals A over sine 75. Okay, that's not really too helpful, because whilst we can work out what sine 30 is, sine 75, we're not able to work out the exact value. So let's try the cosine rule. So I'll call it RT squared. So A squared equals, remember, A squared equals B squared plus C squared. Take away 2BC cos A. RT squared equals A squared plus A squared plus, take away 2. A times A cos 30. So this equals 2A squared, take away 2A squared cos 30. So let's draw our triangle. 2, 2, 1, 1. This is root 3. 60. This angle is 30. So cos 30 is adjacent over hypotenuse. So root 3 over 2. Of course, you could use a calculator. So root 3 over 2. So we have 2a squared, take away these two cancel out. So root 3a squared equals a squared 2 take away root 3 . Bear in mind this is RT squared. So now let's square root both sides. We get RT equals square root of a squared is a, and 2 take away 2, 2 take away root 3. Yeah, so that is our RT value. Hence prove that sine 15 equals this. Okay, so sine 15. I always think to myself, where are they getting the sine 15 from? So this triangle at the bottom, so this angle is 5. So we have 150 to 110. So this angle is 150 degrees. Angle here and a 15-degree angle here. Now let's use the sine rule. So sine 15 over, I'll write RT for now, equals sine 150 over A. So that's sine 15 equals sine 150 over A multiplied by RT. You know, instead of writing RT, now I'll write where it actually is. So A these two cancel out, and all that is left to do is for us to prove that a half equals sine 150 by drawing a sine graph. So it starts, we know that sine 30 is the same as sine 150, right? This is 1, this is a half, and again using this triangle up here, I can prove that sine 30 is opposite, which is 1, over hypotenuse, which is 2. Question 9 is a coordinate geometry question. So one thing I'll say with these questions, and to be fair with most mechanics questions, I know this isn't mechanics, but with most mechanics questions as well, I think the first thing you should do is always draw a diagram of what the information, or draw a diagram based on what the information is telling you. So here I will plot these coordinates on a set of axes. So -2, -3 is here, 4 and 1 is here, and 2 and 5 here. Find the midpoint of each side and hence find the equations. So midpoint of E and F is 2 plus 4 over 2, 5 plus 1 over 2. That's 3, 3, 3. Okay. Oh, sorry, I shouldn't say midpoint, because okay, now I'm going to plot these coordinates. So we have 3, 3 here, -1, -1 is here, and 0, 1. Oh, okay, here. Wait, 0 and then 1. Okay, here. One thing I need to do is make this actually look like a triangle. So I'm going to join these points up. Okay, it's not the best triangle, but it's good enough. Find the midpoint of each side. We've done that, hence find the equations of a free median. So here it says a median is a line from a midpoint of each side to the opposite vertex. So we have this one, and a third one here. So it's worth noting what these coordinates actually are. This is 0, 1, and here we have 4, 1. So this median, I'll call it L1 because I've used M already. L1 equals, I should say, L1 has the equation y equals 1. L2, I'm going to call this L2, has the coordinates 1, -1, and 2, 5. Okay, so 2, 5. So the gradient is 5 take away -1 over 2 take away 1 equals 6 over 1, so 6. Okay, and it makes sense, it's quite a steep gradient. 6 and the y, and so we have y equals 6x plus c. Now substitute 5 into this. We get 5 equals 6 multiplied by 2 plus c. So c equals -7. So I write y equals 6x take away 7. Now for L3, we have coordinates 3, 3, and -2, -3. Same method as L2 really. Work out the work out the gradient. So 3 take away -3 over 3 take away -2 equals 6 over 5. 6 over 5 substitute 3 into this equation and we get 6 over 5 multiplied by 3 plus c. So I'll rewrite everything so that the denominators are 5. 15 over 5 equals 18 over 5 plus c, and so c has to be -3 over 5. 3 over 5. So L3 has the equation, it looks really messy now. L3 has the equation 6 over 5 x plus, take away 3 over 5. The screen was getting really messy, so I rubbed out all the information and I've kept the 3 equations. Now we're going to answer part 2. Show that the point 4 over 3, 1 lies on each median. So essentially what that question means is prove that this point of intersection is the point 4 over 3, 1. So firstly, y has to equal 1. Just looking at that first equation, our y value has to equal 1. Now we're going to work out x using these two expressions. So they're both equal to y, which is helpful. So we're just going to set them equal to each other. So I'm going to add 7 to both sides. Alright, 7 here for now. And I'll subtract both sides by 6 over 5x. 6x take away 6 over 5x. So 7 is the same as 35 over 5. And 6 is the same as 30 over 5. Yeah. So we have 32 over 5 equals 24 over 5x. So multiply both sides by 5. We get 32 equals 24x. So x equals 32 over 24, which is 8 over 6, 4 over 3. Yes, 4 over 3 is correct. And so we've answered that question as well. Question 10 is another coordinate geometry question, and it looks similar to the previous question, but actually the reverse. So they've given us the equations, and we need to work out the coordinates of the vertices of a triangle. So we have 3 lines, so I'll write L1, L2, and L3. Just gonna draw a set of axes with 3 lines forming a triangle. So we need to find the coordinates of the vertices of the triangle, and whenever you have this type of situation, these 2 lines intersect at this point, these 2 lines intersect at this point, and these 2 lines intersect at this point. So we'll need to find those 3 points of intersection. So I'll write P, L1, L2. So essentially we're solving simultaneous equations now. Okay, I'll rearrange this and write 11 take away 3x. Here we have I'm going to substitute this into here. So we get 33 take away 9x, x plus 3. Take away 3 from both sides. Add 9x to both sides. So x is a third. X is 3. So substitute that into this equation. Substitute it into this equation. We get y equals 11 take away 3 multiplied by 3, which is 11 take away 9, which equals 2. So the first point of intersection is 3, 2. The second point of intersection we'll use this. And we'll substitute it into here. So we have 77 take away 21x plus x equals 37. 77 take away 20x equals 37. So we have 40 equals 20x. X equals 2. Now substitute x equals 2 into this equation. And we get y equals 11 take away 3 times 2, which is 5. So the second point of intersection is 2, 5. Lastly, the point of intersection of the second and third lines. Let's say 3y. There's this. 3 from both sides. We have x equals 3y take away 3. We've rearranged the second equation, and now we're going to substitute it into the third equation. So I'll replace this x with 3y take away 3, 7y plus 3y take away 3 equals 37. So we have 10y take away 3 equals 37. 10y equals 40. So y equals 4. And now we're going to substitute y equals 4 into this equation here to work out the x value. X equals 3 multiplied by 4 take away 3. 12 take away 3 equals 9. So write 9, 4. So we plotted our points of intersection on a graph, joined them up and labelled our 3 lines. And so for part 2, we need to show that this triangle is indeed a right angle triangle. Now, I know it looks like a right angle triangle, but we need to prove it. So one way we could do that is by proving that the gradient of this line and this line, the gradients of these two lines are perpendicular. So line L1 has a gradient of -3. So right, M1 equals -3. L2 is here. X over 3 plus 1. So the gradient is 1 over 3. So yeah, M1, M2 equals -1. So this is indeed a right angle, and so the triangle is a right angled triangle. Work out the area of triangle of a triangle. We need to use Pythagoras' theorem. So 6, 2, I'll call this x1. Actually, x2 would be more suitable. x1. So this is 1, 3. So x1 equals 3 squared plus 1 squared. x2 equals 6 squared plus 2 squared. Root 10. Root 40, yeah. So the area of the orange triangle is half multiplied by the height multiplied by the base. So half root 40 root 10 root 40. And so let's simplify this. So root 4 root 10 root 10. So root 4 is 2, and so it cancels with this, and so we are left with 10 squared units.